Hello, my name is Professor Matthew Wright, and I am going to give you a brief introduction to using Microsoft Excel. Now, this is a quick overview, right, of doing something that you have to do for your lab. So last week in class, you did the PVA Lab, or the Position, Velocity, and Acceleration Lab. And what this little brief video in Excel will do, will just give you an idea of how to do that calculation in Excel, right? Now, doing calculations on the computer are a win because it allows you to do a lot of calculations in a really short amount of time. However, they're difficult because there's no flexibility. If you make a mistake, you're going to make it 1,001 times, right? It's just going to keep making that mistake over and over and over again. So be patient, be thorough, make sure you go through your processes step by step by step, and you'll be okay. You will make mistakes, but you can fix them. All right, so what we're going to do is we're going to turn your data into an analysis that we're going to put on Excel. Now, when you open up Excel, you get something that looks like this. It's kind of somewhat intimidating. There's a bunch of cells. That's what they call each block in here. They call it a cell, right? There are columns, like this column is E, the E column, and there are rows, like the 10 column. And so if you go to E10, that's a cell, right? It's in the E column, 10th cell. Some of you guys are going to be experts at Excel. Some of you guys will have never used it, right? So a little bit of introduction, but we're going to get to calculations pretty quickly. All right, it's really super important to write notes in your Excel sheet because later on in the future, somebody, it may be yourself, will want to open up this Excel sheet and figure out what happened here. And if you don't have notes, I promise you, you'll forget. Even if you write it, you will forget it because, I mean, this kind of stuff just goes away in your brain, right? In memory, you just forget these kinds of things. Trust me, I know. So I'm going to go to cell A1 and I'm going to write a note to myself or whoever else might open this. This Excel file calculates, this Excel file does analysis related to the PVA Lab for Physics 113, right? Or Physics 111, if that's the class you're in. All right, I might even put some additional information like it was created by Matthew Wright, July 21st, 2020, right? So just giving the user information about the program. Now, sometimes this will go on. When I was a management consultant and I used Excel every day, right? Like every day, I would have notes that just, you know, went 10 rows down of like what my calculation was going to do, right? And so one of the really important things about Excel, like a tidbit of Excel, is that when you go and you major in physics or chemistry or biology, you spend a lot of time learning lots of different calculation tools. You might learn how to use Java, you might learn Python, you might learn MATLAB. The biologists do a lot of statistics, so you'll learn like these various statistic packages. But then you go and you get a job someday and you're working in corporate, right? And while you're working in corporate, you realize that everybody is using Microsoft Excel. Because if you go into business school, they almost exclusively use Excel to do their work, right? So like all the executives are masters of Excel. So whenever you want to communicate information to the elite of your company or the business elites of your company, you're almost always going to be using Excel to do so. So getting to be good at Excel is pretty cool. All right, so let's do some analysis. All right, so here's the data I took right here in my experiment. I have time and position. I want to make a title for my time, so I put it in. make sure I put my units, right? So here I have feet, so position, position. I'm gonna put that in feet. I'm gonna bold these guys so that it looks sharp. So like all of the office tools, you can go here and you can bold and do all kinds of other formatting thing. I really like to use strike through on checklists. So I'll make a list of things I got to do, and I use the strike through to tell people when I'm done. Well, you know, whatever. All right, now let's input the data. All right, now if you look at the time column, it's got data in a regular pattern, right? So the first point is 0, the second point is 1, third point is 2, and I can type those in by hand. But I'm going to show you another way to do it. I could put 0, the first point, into the A5 cell. Then I can go to the A6 cell, and what I can do is create an equation. Now, if I just start writing things in there, it just, that stuff goes in the cell. But if I put an equal sign, that starts an equation. I can click on the A5 cell, and then I can do some arithmetic. So I put +1. So what that's going to do is that's going to take the information in A5, it's going to add 1 to it, and put that information into the A6 cell. So 0 + 1 is 1. Now if I copy this, Control-C, and I paste it, Control-V, and I go and I look at the equation in A7, Excel has already done a magical thing for us. It has updated our equation so that it now makes sense in the A7 cell. It takes A6 + 1. So it adds 1 to 1 and gives me 2. Now, you could copy and paste, keep going, or what you could do is just grab this corner and fill it down. And you'll notice that it just keeps moving the equation down as it goes down, right? So this is a cool way of inputting a lot of numbers in a regular format. So I only have numbers from 0 to 7, so I'm just going to go ahead and delete these. Bye-bye. All right, now I don't have a regular pattern here for the position, so I am going to do 0. I'm just going to put them in 1.5, 2.4, 3.3, 4, 4.7, 5.6. So this is my position in feet, right? And now maybe I want to convert that to SI units, right? I mean, who likes using feet? Okay, so what I might do is the following. Take my headers, right? And then here for the position, I might make this meters, all right? So I would go equals A5, and that's going to put the contents of A5 into D5. And if I fill that down, that's just going to take everything that's in this column right here and port it over to the D column, right? So in a way that's kind of redundant, but I always like to keep my X and my Y's together so there's no confusion. All right, now to convert. All right, so this is a lot. The first thing we're going to do is convert to inches, right? So new, good. All right, so if I have something in feet, so enter equation. So if I have 3 feet, right? And then I want it to go into meters, we're going to have to do a unit conversion, right? So let's see here. So I know that 1 foot is 12 inches. Okay. And I know that 1 inch is roughly 2.5 centimeters. Now that's just something that I have memorized, right? Now you might want to look that up on Google or what that exact unit conversion is, but that's just something that I know in my head. Okay, so, and then I know that there are 100 centimeters in 1 meter. So to do the unit conversion, I'm going to do 12 times 2.5 divided by 100. And that will convert feet to meters. Okay, so let's go back over to Excel. So I do equals 12 times 2.5 divided by 100 times the number of feet I have. Okay, that writes down an equation for the position in meters. All right, so 0 feet gives you 0 meters. And again, what we're going to do is we're going to fill down. So doing this conversion for each value. Right, and then you get a nice conversion here. Let's see if it makes sense with our gut. We know that there are 3 yards in a meter, or sorry, 3 feet in a yard, and a yard and a meter are about the same. So if I take 3, I divide it by 3, I get about 1, right? So it's about 1 meter. So that kind of makes sense. All right. So now what might be helpful is we might want to plot our data to see what our position versus time looks like. So we can highlight all of our data. We can go to Insert, and then we can choose this one right here, which is the XY scatter. Just choose the top one, and you get this. And so this is our data, and we should definitely label things because that's the most important thing on a graph. If you don't label things, you won't know what you're doing. So we're going to go ahead and put a title in here. We're going to do position versus time. And now we got to label our time and our position. So we're going to do design. And if you look here, you can add axes to this. So you can add an axis title, primary horizontal. Come over here. You can write time in seconds. And then over here, you can add a axis title for the vertical. And again, you're going to make sure you put the units, position, meters, right? So you have each one of these values is an X and a Y. Now, okay, so one of the things that you often learn when you do Excel for the first time is you learn how to do something called the line of best fit. Okay, so what you do here is you can click a point, right? And you can do this thing called add tread line, right? And then this thing comes up, you can select what type of fit you're going to do. This looks like a straight line, so we're going to do a linear fit, right? And then what a lot of people will like to do is say display equation on chart. It'll put your y equals mxb on your chart. Okay, now if you open up scientific journals, they almost exclusively don't do this, right? They don't put this equation on the chart, right? They just don't do it. So we might want to get that information in another way. So what you can do is just show your line of best fit, right? And you can get this by using the line ST. A little thing pops up. It says known Y's, known X's. So I go over here and I say, well, I'm going to highlight all of these because they're my known Y's, comma. Then I'm going to highlight all of these because they're my known X's. And then a little tidbit, there are these 2 flags you need to do. It'll tell you what they are. Just set that to be true and true in almost all cases. Close, and you get a single value. What is that value? It's the slope of this line, right? Ugh. But there's much more information you can get. So if we do the same kind of thing, and this is kind of a weird Excel-y thing, so I had to look it up, right? So sometimes you don't know, you just start Googling things until you find it out. So you do is you highlight 2 columns, 5 rows. You go into this cell, which is already highlighted there, and you write equals line ST, parentheses. Now you do the same thing. You do your Y's, comma, you do your X's, comma, true, comma, true, right? Close your parentheses. You got to make sure you close your parentheses. And then you do something really wacky as well, which is Control Shift Return. And it gives you a whole bunch of numbers. What do those numbers mean? Well, I went and I looked it up. All right, so here's just a quick aside. This is using a method called least squares fit. It's basically a statistics method for fitting lines to data, fitting straight lines to data. It is absolutely perfect and completely analytical. You can solve it with pen and paper. It's not a terrible process. It's a little bit beyond the scope of this class, so I'm just gonna kind of brush it under the rug and go on to the results. So if you use the lin-st, and so again, I had to look it up, lin-st, I did a Google search, right? And I got some help. And you just, read through this document, you get to this really nice figure here at the end of the page, which explains what are all the values, right? The slope is the first one, and the second one in the first column is the uncertainty in the slope. The first one here in the second column is the intercept, and the second one is the uncertainty in the intercept. So if I look at my data, this is my slope column, and this is my intercept. Remember that we can write down the equation as y equals mx plus b, where m is the slope and y is the intercept. So I would say that my velocity here, right, my velocity, which is the slope of the position versus the time curve, right, is going to be equal to 0.239 plus or minus the uncertainty, 0.003, right? So what I did was I said that my slope, that's my velocity, right? And the intercept, sorry, the slope's error is 0.003. So the uncertainty in my velocity is the number on the right? And the value of my velocity is the number on the left. Cool? All right, let's talk about one more thing. What if we wanted to get the position, we got the position as a function of time, what if we wanted to get the velocity as a function of time? How might we do that? Well, we know what our time is, right? Time is in seconds, and we know our velocity. That's what we're looking for, right? Meters per second. Okay, so we're gonna make these bold. Now, what is velocity? Well, velocity is the change in the position divided by the change in the time. Okay, so if I go to this point here, we can do, let's do the following. Let's do the position. Let's do change. Let's just do dx for change in position in meters. And let's do dt for change in time in seconds. What's the change in the position? Well, it's the E6, right, minus E5. That's a change in the position, right? How much the position changes in a given time, right? We're basically finding the slope at that one point. the slope of this point right here, the line between these two points. And the time, right, the change in time is going to be this minus this. So then the velocity is just the change in the position over the change in the time. Now I can grab these, highlight them, and I can fill down. So you highlight them and fill it down. Now, a little caveat here. What you don't want to do when you do this, you want to make sure that when you fill down, that you don't go down to the bottom row, right? Because you need to know the difference, right, between 2 points in order to calculate dx. But if I go to this point, it's the difference between this point and you don't have that data point, so you can't find that difference. So you end with one less time, right? And then I like to do another little thing, right? Because when you do the time, it's really weird because are you looking at the slope at the 0 or at the 1? And the reality is you're kind of looking at the slope in between, right? Are you getting the slope at this point? Or are you getting the slope at this point? Or are you getting the slope approximately in between? And I think the in between is what you want. So what I'll often do is do the average of these 2 points, right? Which in this case is 0.5. I can fill that down. And now I can create the position versus velocity, or the time versus velocity graph. I can use the control button and highlight both of these. I can go to insert. I can insert my my velocity here. Then I can go and I can label it. Velocity versus time. And the same kinds of things as before. Add my chart titles. So this is going to be velocity is meters per second. And here we go. And this is time, which is seconds. Okay. Now let's see if that makes sense. What would be the average velocity? Well, I could take this point here and go average and take the average velocity. And that gives me 0.24. But what did my fit tell me? Well, my fit told me 0.039. Huh, that makes sense, right? They're about the same. We can also find the standard deviation in that average by doing STEV. That's basically how much error we have. We can highlight these. And that gives me 0.03. And if I look at, and now if I look here, the statistical uncertainty of doing this calculation was 0.03, whereas the statistical uncertainty here was considerably less when I did the fit. This way. So doing the fit of the data is a preferred method for finding results like the slope and uncertainties and other parameters. Cool. So this is a quick introduction to Excel. There's a lot of information here in a very short amount of time. I hope you learned something. What I would do is go through this thing in Excel yourself and try to input your data and then contact me or your instructor to see if to help answer any questions you have as you're doing it. Have a great day, guys. Rock on.